Hi everyone, I'm going to show you how to use KiCad to make your own PCBs. I am in no way an expert on both PCB design and PCB CAD software, but hopefully by the end of this tutorial you should be able to do basic projects that you would need and get you started on what needs to be done. So we're going to use a program called KiCad, which is an open source PCB design tool. There are other ones like LTM and Eagle, but they have a cost associated with it. And for our basic purposes, we can use this tool, and it's good anywhere from using it as a hobby grade tool all the way up to professional, depending on how much time you want to put into it. Now it is open source, so it can still be a little bit buggy, but it's more than enough to be workable with. So first let's open KiCad. When you first open KiCad, you're welcomed by the project screen. So the project screen has a couple of things that are interesting to note. All your projects show up here on the left in a tree format. We can add and create new projects using this link here. We can get to the schematic view using this, the schematic library from here, the printed circuit board editor, the footprint editor, Gerber view, bitmap to component conversion. So if you want to add your own logo, you can click on this, and if you have a bitmap image, you can convert that into a component, which then you can place on your board. The PCB calculator, you can input all of the components that you're using on your board and calculate a cost for it. And then a PI tool, a PI editor, which I've never really used before, so I'm not too familiar with that one. So let's first start off by creating a new project. I'm going to create a new folder. I'm going to call it First Project. Okay. Double click on this folder, and I'm going to say First Project for the name of the project that we're working on. Hit save. Now you can see that it shows up here with three things. It comes with the first project project file, the schematic file, and also the PCB file. So let's start adding some components. Now the workflow for this is that we need to we can only send Gerber files off to the manufacturer house, which basically a Gerber file is a photo for each mask. Now for the most part, when you make a PCB, you want to make a two-layer board. So that means that there are two layers of copper. There's a mask that goes over it to cover the copper and protect it from being shorted out, and then there's silkscreen, which is where all your labels and things can be printed onto. So if we click on the schematic view, we get a nice drawing page that we can start adding our design to. So each one of these dots is a different grid, and you can see that it snaps to the, let's zoom in, I can snap to each one of these points on the grid. You can change the grid by editing the page settings, but for the most part this is not critical. We can add components on the right, place different power on the right, and also wire things together on here, as well as labeling and other types of graphics that we want to add to this. So let's start by adding a couple of resistors to this project. I can filter between 2,500 components, so if I hit R, I can add the component that we want. So I want to add 3 resistors, so if I look at R, I get a whole bunch of different ones. This is just a plain resistor package. I need to add 3 of these. Okay. Now I can move these around by hitting the Move tool, which is just hitting M on the keyboard and then clicking on the object, or actually hovering over it and hitting M. And if I single click, it will place it down. So I have 3 resistors here. Now the next thing that I want to add is I want to add an op amp to this. So the one that you guys have been using is the TL074 ACN, which doesn't show up in the objects, but it does come up with the TL074 quad op amp MOS package, and you can see that it has the pinouts for each one of these components. for unit A, B, C, and D, and it changes the pins accordingly to what the inputs and outputs are. Now, I've never really worked on how to do all of these into the same component, so for us, it's actually easier to deal with if we make our own component for the TL074. So for now, we'll just hit cancel. We'll make our own component for that by going over to the schematic library editor. Okay, that shows up this page here. We need to create a new component, so we click on create new component. I'm going to name it TL074ACN. The designator is a reference. You can change that to your own library needs. There's a standard for it, but I don't really mess around with that too much. And I hit OK. Now it's going to create the labels for it. I can move those labels again by hitting the M and moving it up and out of the way. Now, let's look at the pinouts for the TL074, which I'll bring up the data sheet over here. Now, the one that we're using is this package type here. So out 1, in 1, all of these. There's 14 pins that we need to add to this board. So what I want to do is I want to hit add pins to component. Pin name, I'm going to call this pin name 1 out, just like on the data sheet. And it's pin number 1. Now, if you look on it, it says orientation right, which means that the label is going to be over here, and this is what you connect to on the board. So I hit OK, and I can place this pin here. Let's add the next one. So this is 1 in minus, pin 2, hit OK. Now there is an easier way to add all of these at the same time, but I don't use that tool very often, so I don't remember exactly how to do it. But there is a way if you have a pin that has a lot of components that you can just add everything at the same time. So you can name these whatever you want, but I'm just following the same convention that they're using on the data sheet. It's pretty easy to follow, so it's not too bad. This one is 5. You can see that this is all for the left orientation, so we can move this if you were trying to add pins on top and pins on bottom by changing these guys here. I have to move this down, so let's move that down and continue adding pins. Now these numbers are important because you need to specify what this is being connected to on the footprint, and the footprint is referenced to these numbers. So like 1, 2, 3, 4, 5, 6, 7. There's a standard convention for this. Now we need to add one on the left, so I'm going to hit left. Changes this orientation around. 4 out. 14. See, I didn't add the pin numbers to these guys, which I need to go back in. I can edit these pins by hitting E, and it shows up this again. This is 13. If you fail to do this, when you try and associate this component, it will not come through. Let's see, so this is 12. Again, if you have a lot of components, this can be very tedious. But every single time that you do this, at least you should only have to make components once. So once you build up a library, you never have to do this again. Or at least that's the idea. Okay, now we've added all the pins that we want, and we are just going to make a very simple box outline to finish this shape off. So this just makes an, should add graphic. There we go. Okay, and hit cancel, and I'm just going to highlight this whole thing and move it down just a little bit so that at least it's somewhat centered on the center of this pin here. That's pretty good. Just move this up here. Okay, so now we have a new component, and we have the name and the pinouts for this guy. Now, the next thing is I have to add it to a library. So I'm going to create a new, save this component to a new library. I'm going to go down and go to the 3 terabytes and save it in the same project folder. Now I'm going to call this library, or I'm going to name this file as TL074ACN, but I want to rename this as a library that I'm going to use. So I'm going to call this EC2001. And I hit save. Okay. Now I want to select the working library. I can go down and I need to add that library first. So let's go to component libraries. I want to add here, and I want to find that same library file that I had. So it's in the same guy here. Okay, so this is the library file. I hit open and it will add it here. So these are all the files, all the libraries that I have so far, and I hit OK. And then I can select the working library and it should show up. There it is, EC2001. And then after I do that, I can say, okay, I want to update this current component in that library. Alright, and after I update it, I can save this current library to disk. And now we have this new component which we can add in the schematic view. So let's close this guy, go back to the schematic. Where is it? Okay, here's the schematic. I go to add components. Now if I look for my library, which should show up EC2001, I can click on this and I have the op-amp that I made. Okay, so now this op-amp is here. So let's make just a simple non-inverting amplifier for this guy by moving this component left here. I'm moving this resistor over here. Can move this resistor up here or so. I'm not going to make it very neat. You can spend a lot of time working on this. And we're just going to wire these together. So for us, we're going to wire this guy. Oops. I'm just going to move that over, I guess, a little bit. And I can hit the wire and wire these two guys together. Oops. And we have our basic feedback. Now I can also edit each one of these components by hitting the E, and I can change the value of this guy. So for us, let's make it 100 times gain, so we're going to call this 99K. Okay, that changes the value here, and I can edit this to, oops, and come on. Oh, I'm hitting the rotate by accident, sorry. Out of there. Okay, sorry. And I want to call this value, and I want to make that one K. Okay. Now the next thing is that I need to add a ground to this system, so we're going to go over here. We're going to place a power port. Now these are just references, so if I want to call ground, I can just go down here and I'll add this little flag, and anything that I connect to this will be of the same node. Hit cancel. Okay, so I have a ground there. Now the next thing is I need to add power for this chip. So we'll go over here again, and I'm going to power it with 12 volts. So if I press 12, I have plus 12 and I have minus 12. Again, these are just references, so I don't need to be exact. As long as I reference everything to the same one, it's fine. So 12 volts. And let's make a minus 12 volts. So we go over here and place the minus 12. Okay. Now you can make your own flags too, but it's easier just to use the ones that are there already for most of the things. Oops. Of course I accidentally moved it, which means I broke all of the wires connecting it, so let's reconnect those. Okay, so now we have the op-amp wired in, and we have 2 resistors. And the next thing that we should probably add is a source. So we're going to add a microphone to this. And let's see if they have any microphones that are two terminals, because that's the one similar to the one that we're using. It doesn't seem like there is any, so we should make our own microphone too. So we'll go back to the schematic library editor. I go over and I say I want to create a new component. I'll just call it mic. Hit OK. And I'm just going to move this up and move this down. I'm going to add 2 pins for it. I'm going to call this plus, and this will be on pin 1, and we'll hit OK. And we're going to call the other one minus. We're going to call that pin 2 and hit OK. And we can add a circle for this body. Let's see how well that will work. Oops. Cancel. And we can do something like that and move this down. So this kind of looks like a microphone a little bit. That's pretty good. Now you can spend a lot more time working on this, but we're just doing this nice and quick. So that's our microphone. I want to update to the current library, which we're selected the working library that we're using already. So I update this component, hit yes, save. Okay, now in that same library that we had before, if I go to add it, I should still have the microphone. So if I go to EC 2001 here, I also have the mic, which I can add. Place it here. Okay, and then we just wire it as we would normally. So let's add this resistor up to here. Okay, the other one will go to ground, so we just add our ground like that. Okay, and then let's add a capacitor. Now they have different types of capacitors, but for us we're just going to choose a small size capacitor. Rotate it by hitting R. Oops, cancel. And then I can connect that there. Now I can also use a flag to move it over here, or I can just draw around it, which I think we'll do for this very simple circuit, because it's not like we're trying to make it that neat. And then we need to add another resistor to ground. So let's add another resistor. Okay. And then we add the ground here. Hit OK. And there you go. We have the main components for this guy. Now I need to add another voltage source. So let's go over here and press in 5. I'll add a 5 volt source. Now this flag is different, so it won't connect to the 12 volts. Hit cancel. And we have a nice setup so far. Okay, so we have our basic schematic done. Now we need to have an output so that we can actually connect to it. So for our output, I'm going to add a 2-pin connector to it. So if I go over here, place component, we're going to use one of the ones that they have already, connectors. we're going to use a 1 by 2, so this is one row of 2 components. I'm going to add that there for now. Again, if you're working on a much larger project, you want to make this as neat as possible to be able to see what you're doing, but for us, we're just going to make this nice and simple. And so we have all the basic components that we need for now. We should also add another component for all of our power stuff. So we need plus 12 volts, minus 12 volts ground, and a 5 volts, so we need a 4-pin connector. Let's see where the connectors are. Connect, con, and we need to add 4 pins. Okay, we'll put this down here. Cancel. And we need to add plus 12 volts. Rotate this with R. Add another one. Make that minus 12 volts. Rotate this with R. Another one. 5 volts. And then ground. Now this order, depending on how you do this, again, these pins are what are physically going to be the connecting point for each one of these guys, so you need to keep that in mind. Cancel. Whoops, cancel that. We'll just wire these across like so. So on pin 1 of this strip will be 12 volts, and then on pin 4 will be ground, so that's the one that you want. So now we have our basic component completed, our basic schematic completed. So the next thing is that we need to associate these components with footprints, what these are actually going to be connecting to. So we can do that by going over here and saying run CV PCB to associate components with footprints. We want to do the entire schematic, want to annotate it, and it'll show up once it loads. Give it a second. See, these are all the components that we've added with their references. So R1, R2, R4, R3, each one of these goes down. So what we're going to do is that we're going to sort these by library. So you can sort these by footprint keywords, the number of pins, or by the library that's in. And it's easiest to find these by the library that's in. These are all the libraries that we've added so far. So let's start with the capacitor. So we want to go to capacitors, through hole, and there's a whole bunch of different sizes. So depending on the capacitor that you want to use, you want to choose the correct size that you want. So for us, we're just going to use a standard 8mm diameter with standard pitch, horizontal. No, we want vertical. See where it is, or maybe they don't have that. These are the different lengths. So we'll use a diameter of 8 and a pin pitch of 26. So we'll just click on this guy. Now if you're unsure of what the component actually looks like, we can look at the selected footprint. And so this one's horizontal. So if you had an axial capacitor, you could actually mount it like this, but that's not exactly what we want. So we want a vertical or radial, that's what it's called, and we want a pitch of this one. So this is a pretty standard size for capacitors. We can look at this one. We can then double click on this because this is what we want for this capacitor. Again, this will change depending on which one you want. So we added our capacitor, it shows up here. Let's add our connectors. So we go over and we say we want to add some pins, so we'll just go down and look for pin headers. We'll use a straight pin header and pitch of 2. So the pitch is the distance between each pin. Depending on which one you're using, you might want to choose 0.27 or 2. So we'll just do pin pitch of 2. So this is a 1 by 2 connector. Click. We need the 4, so we go down here and we do the same thing. Now for the resistors, we can go over and find resistors, which are R. See, resistors through a hole. And we'll just use the standard horizontal, because we want to put this on the board, horizontal resistor. Which, we usually want to use, let's see. Let's take a look. Is this the right one? Yep, we can use this one. Actually, we'll get a little bit more space because I think most of these are a little bit bigger. So this is the length, is 3.6 millimeters. Actually, we want to use a longer one, so we want to use length horizontal of at least 6.3 millimeters. So we want to use this guy. We can look at that. It gives us, that fits most quarter watt resistors pretty well. So we need to add 2 of those. Okay, so all our resistors have been added. For this guy, we need to look at the dual inline packages. So if we look at the data sheet, we can say, okay, look, this, they have more down here. So the pin that we're using, or the model that we're using, is a through-hole one. So where is it? There it is. So they're using PDIP package. You can get all the dimensions here in case you have to make your own view, but for us we're going to choose this one. So we need to look for dual inline packages, which, let's see, where do they put those? Pin headers, potentiometers, relays, sockets. Here it is, dip. Okay, so we need an 14 dip, and they have a couple of different ones. They have SMD socket, but we want through hole. So let's see if they have 14 dip. The width is 7.2 millimeters. Let's just check that. And the width here is 7.62 from that point. So this should be, yeah. So if we look at it, yep, that's the one that we want. Hit OK. We add that for this guy. Okay. And then the microphone. Well, let's see if we even have microphones. So if we don't have microphones, we'll need to make our own, which is fine. And we can learn how to do that very easily. I'm just going to save this footprint schematic for now. So we save this. And now all those components are associated with those footprints. I can close that. So we need to add a footprint for our microphone. So if we go back to our guy over here, PCB footprint editor. So this is basically the same thing as the other one. Now I'm going to make this full screen. I'm going to zoom into the center here. Now this is where the grid is important and the distance is important, because we need to get the actual dimensions right so that it fits on the board. So we're going to start by doing a new footprint. We're going to call this one microphone. So let's look at the data sheet for the microphone. Whoops, wrong screen. Just going to move this over. So new footprint. We're going to call this just electric microphone, and hit OK. And it's going to create the same thing that we had before. So this is very similar to when we were making the components, but it's a little bit different in a way. Now, because this is symmetric, it doesn't really matter too much for us, but we need to add some pins for it. So let's add the first pin and the second pin. There's 2 pins, so you can see that this is pin 1 and this is pin 2. Now let's edit the positioning of these pins so that we get the spacing right. So the spacing between these 2 guys in millimeters, which we're in millimeters right now, is 2.54 plus or minus 0.3 millimeters. So let's edit the first pin. Okay. edit, please. Okay, now this is pin number 1. The drill size is, so this is 0.762 millimeters across, which should be fine. It's a little bit larger than the 0.45, and you always want to make these larger. This is the diameter of those guys, so that's fine. We don't need to move that. Right now it's at position 0, 0, which is also fine. And the outer side, so this guy right here, the diameter of this is 1.5 millimeters, so that's also fine as long as it's not conflicting with the other one. So we don't need to move this. Now this layer right now, it's on the front silk, which doesn't help us any. We need to actually make that on the front and back, front and back. Yeah, so it's on the copper layers already, so we don't need to. There we go. Yeah, so right now it's on both the front copper and back copper layers, so that's fine. So we don't need to move the first pad, but we should move the second pad so that it fits the spacing right. So if we hit edit again, right now this position, we need to move it so that it's 2.54 over to the right. We don't need to change any of that. And we just hit OK, and it moves it over. So this spacing should be correct now. Now the next thing is that we should put a circle around here so that we don't accidentally add any components next to it. So let's add a graphic. We're going to just create an arbitrary circle for now and then edit it. So this circle, we want it to be basically the same diameter of what this is, and I think this one, yeah, so this one has a diameter of 9.7 millimeters. So if we hit edit, and we want to have this have a diameter of 9.7, so if we say this point here, so if we call the center of this guy is let's see, what is that center going to be? So that's going to be 2.54 divided by 2, so the center should be 1.27, which it is right now, and we want to subtract 9.7. So this this point here should be 8 minus 8.43. Okay, and that should get the, oops, that's not right, hold on. 2.54 CX and then the Y point. If I change this, does this change anything? It does. Oh, circles are a very funny thing. Oops. Cancel. Can I edit this, please? There we go. So Y center is at 0.x. This should have made the correct size, but it feels very large for some reason. But it seems to be correct, so yeah, so that's right. Make sure the spacing is actually correct for these guys. 2.54 millimeters. So it seems that we did everything correctly. So this is now our microphone. I'm just going to move these up like this. Now you can center this a little bit better, but for me this is good enough for this. We can actually shift this over. Actually, let's go ahead and do that. So let's shift these guys over. So this is actually going to be, right now it's at position 0, 0. So we're going to move this left by 1.09 that. Hit OK. We're going to move this to the other one, which is 0.07. Okay. And then we're going to center this circle at 0. Makes it easier for us later. So that goes there. This is 9.7. Okay. And then we can just move this reference up. So if you look at this quickly, this blue is the front silk, which means that we'll print this when we go into the board, and we have this all done. So now I need to create a new footprint, create new library. Okay, now I'm going to create a new library folder for this, so we'll browse this guy, create a new folder. We're going to call this footprints. Okay, and we're going to select this folder, and it's going to add a .pretty on the end of it. So hit OK. Now we have a library for this guy. I need to go over and add the library that we just created. So library on the computer. Let's see, where is it? So I'm going to locate this guy, and it is in EC 2001. Click on this, first project, footprints.pretty. Hit next, and hit next, and finish. Okay. Select active library. Let's see if it shows up. Sometimes this doesn't show up for some reason, or at least not fully. Let's see, make sure that it actually got into the library manager. Yep, so it shows up here. Usually what happens is that for whatever reason it doesn't show up the first time, and you have to restart KiCad in order for it to see it. So I want to save footprint, but it won't let me select the active library, so let me close KiCad. We might need to redraw this, so exit without saving, restart KiCad, save this and exit. I'm not sure why it does this, but you do sometimes need to restart it. So let's see if we can select that library. Yep, so here's the library that we made. Hit OK. Let's redraw that component quickly. So new component, new footprint. So we'll just call this microphone. Okay. Move this up. And move this down. And add pin 1, pin 2. We'll edit these guys again, just like we did before. Okay, add the circle again. Oops. Added the circle so that it's the right size. Oops, cancel. Center, X point, Y point, we'll just call this 9.7. Okay, move this down. So it's very easy to make both the footprints and also the points here. So this is not a big deal. Now, if you look at this, this is actually, these pins are actually shifted down by a little bit, and they're shifted down by 2. So let's move these down just 2 so that we get the right size. So 2. And because it's symmetric, it doesn't matter to us as long as we move them both ways. So we'll move this down by 2. Oops. Oops. Okay, now we have the completed schematic that we want. So we can select an active library, which we already selected, footprints, and we can save this to that. We'll just call it microphone. Okay, so now this footprint is ready. We go back to this and we run the association. Give it a second to load in. Come on. Okay, and we go to mic, We look for the footprints that we made, that library, and we have the microphone that we made, and we add it, and we save this association. So now the association is done. So now they know exactly what footprint they're using for all these components. And the next thing that we need to do is we need to start making the board itself. So this is more for the user to look at, and you have a nice schematic that you can then print out for the project that you're making. But in order to make the actual board, we need to go over to the board view. So the first thing that we need to do is generate a netlist. Generating a netlist, we'll save it in the same thing as our project. Hit save. Now the netlist, what that does is it tells all of the connections that these guys are all into. So if you make an edit to the schematic, you need to generate and update the netlist before you can change it on the board view. And now we can close the schematic for now. Okay, save and exit. Now let's look at the board editor. So when you first launch the board editor, it's blank. There's nothing here. The first thing that we need to do is we need to read the netlist that we created. So if we read the netlist, we can see which netlist it's reading from, firstproject.net. We want to read this netlist. And as soon as we read the netlist, it adds all of the component footprints that we made, plus plus all of the connections. So if I hit M in here, I can move these components, and you can see that these wires are coming. These are the connections that we've made. So we can move these guys around, and it always puts them on top of each other, which is kind of annoying because sometimes when you're selecting these, it doesn't select the right one. So let's move these all so that we have them in a general position. Now, it's hard to see the grid. Let's see. Should be able, there it is, there's the grid. So I'm using a very small grid right now. So let's make the grid like let's make the grid, 0.1 millimeter. Actually 50 mils is good. So that's a nice coarse grid that we can start with. Okay. So this grid allows these components to snap. See, they'll always snap to a certain part. So this is nice to make sure that everything is in line and correctly oriented. So let's start making these in the positions that we want. So I can rotate these just like I would before. I want to rotate these guys in a way that it makes sense for me to make it. So let's put all the power on one side, I guess. Doesn't matter so much to me. Now, when you're designing a PCB, there's a couple of rules that you want to keep in mind. The first thing is that you want to keep these traces as short as possible. I'm not keeping in mind the polarity of this this capacitor. We're just using this as an example. So again, you always want to keep in mind of the actual polarity of the capacitor when you're designing the circuit, but it will automatically show the correct polarity here. Can add this resistor. You can see that when I rotate these, the connections that it's trying to make are automatically connected as well. So we have a resistor here, which we need to add, and I'm going to put the resistor here. This one is the one that goes to ground, so can move that around. This is the feedback resistor, so we can, let's move this guy down a little bit. Now this always takes some fiddling around to figure out what the best way to minimize the tracks that you want to use, and also you want to spend a lot of time making sure that you have it so that it all makes sense to you and it makes sense to anybody else working on this, and you want to make it so that it's the easiest to work on and also minimize all of the other design parameters. Now this is just really quickly being put together, so we're not going to spend too much time working on this, but we're gonna just try our best to get these in line so we can move these around. And again, I'm just hitting the M tool to M key to initiate the start of this movement. And then this is our output, so we can put our output, I don't know, somewhere down here, I guess. Now usually when you're trying to minimize for noise, you want to minimize the track length, and you want to also have all the inputs and outputs on the same side of the board. And there's a couple of reasons for this. Mostly it has to do with ground loops. but we're not going to go over those design constraints. This is just to get you started on using the actual program. So now we have a general very messy kind of orientation to this guy, so we can try and make this a little bit better. Let's make these at least in line with those guys. So our microphone and our capacitor, we will move down, and you can see that this is ground, so we'll just rotate it like that. Move this guy down, we can get that in line there. That's not bad. And then let's line up all these resistors with the same kind of, there we go, that's the same kind of spacing. Again, you can spend a lot of time getting this just the way that you want it. We can at least do the power over here. Okay, so we have a basic shape of what our board will look like. It's not, you know, perfect, but it's good enough to get us started here. Okay, so all of these go to ground. This one goes to 5 volts, and we have all of these guys done. So the next thing is that I want to add an outline, because eventually we're going to have to make a board. So let's make the board itself. This is where the grid comes in handy. I want to make a user-defined grid. Let's see, how do I edit the grid? Oh, grid, okay. Okay, so I want to make, let's make this board, let's make it like 20, we'll make this 20 mils wide, so that would mean that if I made a 5, each one of these is 5 millimeters. So let's go down here. Now each one of these is the layer. So this is the front copper, back copper, adhesive, paste, silkscreen, the mask, front mask, solder mask, some other things that you need, and then also the edge cuts. So usually these I don't really mess around too much, like if you want to add comments and things. But first we need to select the edge cuts. So this tells the board, okay, look, this is where we're gonna cut the board. So I'm gonna add a graphic, and I have to select this layer because that's the layer that we're gonna be doing this on. So if we make this 20 mils or 20 millimeters wide, let's do that. So that's 1, so 5, 10, 15, 20. It looks like we need to do more than that, so let's make it 40. 25, 30, 35, 40. Okay, and then we'll just go over to here, we'll add an extra, and now we have the cut. So this is our actual board, and I can hit end drawing at the end of that. So right click and hit end drawing. So this is the actual cut. Okay, now if I do a design rule check, perform design rule check, start that, I can now look at what this would look like in the 3D view. So I hit OK. If I go to view, 3D viewer, I can look at what the board looks like in 3D with all of the footprints. And this is a good way to check to see how well you're doing here. So we have our microphone, our capacitor, all the things. This is what the board would look like if you were to get it printed. Right now there's no traces connecting everything, so we need to work on that next. Okay, so that's what we have so far. Now, usually when you have a board, when you're designing these boards, you want to have all of the signals on one layer of the board. You don't want to feed signals through vias. So we're going to try and see if we can get all of the signals on the top of this board, and we're going to use the bottom as a ground plane. So we're going to make the whole bottom of this thing, all the copper in there, ground. So in order to do that, we're going to create and add a filled zone. Okay, so we're going to go here, we're going to add a filled zone onto the bottom layer. We're going to start. Now it's going to ask, what net do you want to connect to this? Well, we want the bottom one to be ground, so we're going to hit back copper, ground, hit OK, and then we can draw the filled zone. So we're just going to trace this around, and we're going to end and close outline. And you can see that it draws these kind of like cross-stitching showing where the zone is going to be. Now if I run the design rule, perform the design rule check, right now it says, hey look, these guys are not connected to ground, but these are going through the hole, and they have through hole on both sides. So once I run the design rule, this will go away. So I'm going to perform the design rule check, start it, and hit OK. And you can see that these are now connected. And if I look at the 3D view, and I rotate this so I can see the back, I can see which ones are connected to ground. So you can see that it's already made these connectors to ground. Now the reason why it does it like this is to make it easier to solder on, because this is a big chunk of metal. You don't want it to be able to absorb all the heat like a heat sink, and you'll never get it up to the temperature that you need in order to solder to it. So all the pins that we designated on ground are already connected to the ground on the back. So that's pretty easy to do. Okay, the next thing is that we need to add all of the traces that we want. In order to add a trace, we can add tracks and vias here. Okay, now when we design this, we need to create different rules. So if we go to design rules here, I can say, okay, look, I want to add these tracks. Okay, right now the default is 0.2 millimeters wide. The via that it's going to use is 0.6, and the drill that it's going to use for that is 0.4. Okay, I'm sorry, this is the clearance, this is the track width, so it's 25 millimeters wide, and it gives plus or minus 2 millimeters on the side of that so that it doesn't accidentally connect. You always have to have a clearance. So let's add another design rule. I'm going to make this just design 1, so we'll just call this 1, and we're going to change we'll keep the clearance the same, but we're going to make this twice as thick, so 0.5. The via we'll not mess around with because we're probably not going to use that, but we can always change this to something else as well. Actually, we can make this twice as wide as well. Why not? Again, you have to look at standard drill sizes. This drill, we'll see if we can use a 0.8, and that should be good enough for now. Okay, so I can now, since I added that design rule, let's see. Why didn't it add it here? It should have added. Okay. Weird. Why didn't it add the? Let's see. Here. Should have added it to any. So. I should have added the different width as well. Let's see if I can remember how to do this. So if this is the default, I should also be able to change or add all of these. For this guy, I can select all. Okay, and I'm going to select all and add them over there, and it should allow me to. There we go. Now this should show up. Let's see. Doesn't show up. Okay. Let's see. Well, we won't spend any more time on this right now, but should have added another one down here saying, okay, well, we need another track for it, but it seems to not be doing that. So we'll just use the default width for now and figure out why that is not doing it later. So right now, if I were to draw, because I have such a wide grid, it's only going to snap to the grid itself. So we need to go back down, hit close, hit cancel, and we need to add or go back to the grid that we were using before, which was 0.1, which was right here. Okay, it's a good idea to route all of the tracks on the same grid that we were using before. Actually, 0.1 is a little bit too small. We were using 1 before, weren't we? Yeah, here, 1 millimeter. That's good. Okay, now, right now we're still on the back copper. We want to add all of these to the front, so we'll move that up to the front one. And we just simply start going here, right-clicking and ending track. And that drew our first trace for this guy. And then we just do this for the rest of them. So you want to connect here and hit end track, and we can connect this guy. Oops. To the same one. Oops, didn't do it well. I can go back and delete that. And let's try that again. Can add it to this pin here. Or we can try and see if we can get it to. So this is where having them on the same grid works well, because right now it's not on the same grid, so I can't snap to the same node. But I can snap here. So actually it might be better if I just hit cancel for now, and let's just delete these tracks quickly. Tool, and I'm just going to move each one of these components so it snaps on the grid. All we're doing is moving them slightly. So again, you want to always work with the same grid or a division of the grid so that these are not lining up anymore, which is strange. See, these should be lining up when I move these on the same grid, but it's not for whatever reason. This one is. This one is not. Strange. Okay, now those are all in the way that they're supposed to be. Let's try and draw these tracks again. Okay, and track. Yeah, there we go. So we can do things like that. Now you can see that there's one point here that we need to go underneath and connect to this one, because there's no way that I can cross this track as they're on the same layer. So we'll need to figure that out. But we'll do that in due time. And track. And same thing for this guy. Cancel. Let's try and rotate this around the other side so we can so this takes a lot of time. Now there is an auto route tool that you can put in the design rules that you have, and then it will go from there. But it's always better to draw your own tracks, because the tool doesn't always make the best decisions. Especially if it's something critical. You can try and do it for something that's not as important, but oops, cancel. But you know, you don't want to rely on the auto route tool to do this job for you. Okay, so that's done there. We can connect this guy to the same wire, and you always want to do kind of like a branching way so that you minimize ground loops for this. Now you can see here we have an option. We can either go underneath and connect here on the back side, or I can just move. If I move this up here, this is where the orientation comes out. I can have them so that I can still route the signal on the same path and it's not an issue. So like I can do this and then I can route it over here. So you want to place these components in a way that you can minimize going under and around. Sometimes you can't get around that, so like these power guys, we are going to have to route underneath in order to connect them. So we can connect here and end track. And then that's pretty much all of the tracks on the front. All the signal tracks are on the front. We can run these powers to the back, on the back side, and we're done. Now I didn't show doing any vias, but let's say you have to run a track from the top onto the bottom. Let's just show an example. Now via, what it means is we're going to drill through the board and then down. So if I start a track on the top and I hit V on the keyboard, it creates a via. Now see how it's green? Now that means it's on the back. And I hit via again and it comes back to the front. So you can do vias to drill through the board and route things on the back into the front. But if you have, since we're dealing with through-hole components and they can go, they're both connected on the back and the front, we can just switch to the back, switch to the back plane and route these signals, or these powers, underneath. So let's route those powers underneath. So we can hit this, and we can route this, but we should really be using a little bit thicker trace because this is a power trace. So let's figure out why. Now this is showing up as 0.5, so it's actually the larger one of the two. Not sure why the design rule is. Should usually, oh right, duh. Okay, so I was doing it by class list, but I can add it by global. So if I do 0.25 and I do 0.5 and I do 1 and hit OK, I should have 3 global tracks. There you go. So we can add the 1 millimeter track for the back for these power, and you can see that it's much larger than the other ones. And I'm just going to route it down and get it roughly in line. And then we have our power for this chip, and we can say end track. Now the other one's going to be a little bit more tricky because you can see that I have to either fish it through these guys, and you can see these are the clearances, so this is the clearance for the program, or what I can do is I can route it through here and come down on the inside, so I don't have to route through there. So I can do this. Now this isn't really ideal, but it does a pretty good job. So that just shows you how to make some thicker tracks. Now obviously you don't need huge tracks for an op-amp because you're not dealing with that much power. The last track we need to add is the 5 volts, which we can either add on the back or on the front, doesn't matter. And hit OK. Now you can see that I have a couple of tracks that are running underneath on the back side, which means it's going to screw up the ground plane a little bit because this is basically cut off. So this part here isn't really connected to the same part up here. It has to go around and up this way. So that's where this ground loop problem comes into effect. So that's not really ideal for this. So what we should really do is we should move this guy down even more and then run these right next to each other so that we minimize that ground looping effect. So let's do that. So oops, cancel that, move this back onto the back trace. We're going to move this down like this. Actually, let's make this just a thinner track because we really don't need it that large. So we just do like that. And we can route it. Actually, we'll do this. So we'll route it like this. And you basically just have to play around with this so that you, oops, you play around with this so that you get an optimal track. So we'll just run this like this. We can get right close up with the tolerance. Now I can't, it says that I can fit it through here, but let's see if we can actually connect it. See, it won't let me connect it because it's within its tolerance. So we'll have to move this down. And down and then up. Actually, cancel. We'll make this over just a little bit so that it's not as bad. Luckily, since this is a DC track, it's not as important for us, but you can see where all this fiddling around needs to be done in order to do a good job doing these types of boards. So again, this is just a quick tutorial just to get you familiar with how to do this. Now we have all these things done, we just need to redo the design rule check. So let's perform design rules. Is everything good? Everything passes. And now we have a completed board. Now you have to run the design rule check before you can generate the Gerbers. So let's look at the 3D view. If we look at the 3D view, we can see all the tracks on the back. We can see all the tracks we added onto the front. Okay, and this is the best way to check to see, hey, do we do a good job or not for these guys? Okay, so that's what we have so far, and it's good enough just for demonstration purposes. Now, if you look at this 3D view, you can see all of these labels that we want. So this label here is overlapping the other one. Now remember, these light blue is all the front solder mask, so we should go in and edit these so that it looks nice and pretty. So right now we can say, okay, look, these guys are overlapping, so let's move this R4 over. We can move it up here so that it's not overlooking that reference. Now this is where that reference comes in. I can also rename these, so if I hit edit reference, I can rename this to, let's say, op amp. Okay, and it comes up with the new op amp there. We can also put our name on it or add any other text that we want. So we can say, and we have to put on the right one, so we want to go to the front silk. We can say, okay, well, we want to call this ECE 2001 whatever. We can change the thicknesses and all that other stuff, and we can put it here. Why is it? Oh, right, because I selected mirror. So let me do this. We want to display it normally, so we can put that there, and you can also edit your logo and other stuff there. So we can change these designators to whatever you want. So this is where that designator thing comes into importance. So now this these orange ones here is if you were to make like a board to go into a pick and place machine. Each one of those designators goes there, so that would be, oh, where is it? FFab. So these are all on the FFab layer. So if we see right here, but we can make those invisible. If we want to make any of these labels invisible, we can. So for example, on this guy, we don't know which one is which, so let's add labels for each one of these. So the first one, we want to make this front silk, so we want to call this the +5 volts. Okay, and it's still on mirror, and I don't know why it defaulted to that. Whoops. Cancel. Edit this. Normal. Hit OK. And rotate this around again. Now this is where one of those bugs that you can fix by just zooming in and zooming out, and it fixes it. Let's just add the other labels quickly. I don't know why it's defaulting to mirrored. We can call this -12 volts. It's always a good idea to label these, and you can get these in the positions that you want in order to make the board exactly where you want it to be. Hit OK, and I have to edit this by hitting normal, front silk, hit OK. If you hit R, you can rotate these, so there we go. And then the top one is ground. Now again, if you choose a different layer, it will make it on that layer, so you want to keep that in mind, because you could have this symbol be on like the back copper, which doesn't make any sense for you, but if you're trying to just make like a etched board at home, you can do that on the same layer. Okay, so we have all our labels in. This is our output over here, and that's our ground. We don't need to label those. And we have the cutout for the board, and everything's all done for the most part. The last thing is we perform the design rule check one more time just to make sure that everything's in its place. And then we need to generate the Gerbers to be able to send off to the manufacturer. So we go to File, Plot. Okay, And then it's going to ask for what layers do you want to plot all these. So we want to make sure that we select the front copper, back silk, front silk. We don't have any back silk, so we can just select that. The edge cuts, we want to select that one. And we want to plot it and generate the drill file for it. We can put this in the same project that we're doing this. So we just say here. Okay. Drill file, map file, and the report file, same one. We have to generate all of these, and then close it, and hit close, and we should have generated all the files that we need in order to send off to the manufacturer house to be made. Okay, now the last thing is we should probably check those to make sure that they're right. So we just close this, save and exit for now. We go over and we look at them on the Gerber view. So if we look at the Gerber view, I can make this full screen. And I want to load all of those Gerber files. So we can say the back copper, edge cuts, front copper, silk, hit open, and these are all the different layers. So I can look at each one of these layers one at a time, and go from there. Seems that we have most of the things we have right. So this is layer 3 is our front copper. This is our silk layer. It's not showing it right here, but then this is our back layer. This is our cuts, and we can look at the where's the silk? Did the silk show up in that folder? Did I load it? Let's make sure that the silk showed up. Yep, front silk showed up. So which one's the front silk? Yeah, this is the front silk right here. You can see that it comes and goes, and you just want to make sure that everything's here, because this is the final thing that you're sending off to the manufacturer. If everything seems okay from here for you, then you can copy all of those files, which we'll look at real quick. All of these guys, make sure that you have all of these. We'll put this into a nice folder. Call this Gerber, and we want to select all of the ones that we have. So the back copper, the drill stuff, the report. Now this drill file tells the machine where to drill for. So we have the back copper, the drill, the maps, the edge cuts, the front copper, and the back silk. You can put those all into a folder like that. Make sure you have all of the files here, because if you don't send all of them, they won't make the whole thing for you. And then there's another drill file here. So we have the drill file, we have all of our stuff here. And once we have that all done, we make that into a nice zip. And then basically you just upload it to your favorite manufacturer house, and they'll make it for you. So that's pretty much everything that you need to know in order to get started on KiCad. I hope you found this video educational. Yeah, I guess I mean, it's not the best tutorial, but it's good enough to get you going. So let me know if you guys have any questions, and good luck.